For our CS205 final project, we parallelized the Barnes-Hut algorithm for an n-body problem using CUDA. An n-body problem is a simulation of a dynamic system under a force. In our case, we considered celestial bodies acting under gravity. A naive approach to simulating such a system would require on the order of at least n² calculations. For a large enough system, this runtime may be unwantedly long, so we look to shorten it by making approximations. One algorithm that does this is the Barnes-Hut algorithm. This algorithm assumes that the force from distant enough particles can be approximated with acceptable losses to accuracy by using their center of mass and total mass. Doing so reduces the runtime to order n log n. In order to implement this algorithm in serial, we used a quad tree structure, which recursively divides our domain into 4 quadrants. Our first implementation used an adaptive quad tree, which continues to divide the domain until there is only one particle in each leaf node. Using this quad tree, we can compute the center of mass and total mass for each represented box, and then traverse the tree once for each particle in order to calculate the force. As you can tell, this means we must traverse the tree for each particle. This is costly and a good opportunity for parallelization, so we turn to CUDA in order to parallelize the computation of this force. This means that we had to implement recursion on the GPU, which turns out to be quite tricky. At the time of compilation, CUDA does not know how deep the recursion will go, and it's possible to fall off the stack. To avoid this, we set a limit on the depth of our tree and dealt with the case where there was more than one particle stored in a box. As you can see, this version greatly reduced the runtime. Note that this plots on a log scale. And here are the corresponding speedups. Here is an example of our simulation for 1024 bodies.